In this video, we are going to talk about numerical differentiation. So we have a problem that for the given data, x values and y values, we have to find y dash at 3. So we have to find a function y or f of x or the polynomial here for the given data, and then we will find the derivative of this polynomial or function at x equal to 3. So it means that first we have to construct the polynomial for the given data. Now to decide the method with which we will construct the polynomial, we will have to look at the data. The data values are -1, 1, 2, 5, 1, 3. So we have to see that if this data is equally spaced or not. To see that, we calculate the difference between every two consecutive x values. Difference between -1 and 1, and this is how we calculate the difference. 1 minus -1, second value minus first value, so it is 2. The difference between 1 and 2 is calculated like 2 minus 1, and it is 1. So you can see that the difference between two x values, every two consecutive x values, is not same here. So this data is not equally spaced data. So if the data is not equally spaced, then we will have to use the divided differences method. So first, for the 3 points data, we will write the Newton's polynomial. We know that if we have 3 points data, we will first write the Newton's polynomial of degree 2. For 3 points data, the maximum degree of the polynomial is 2, and Newton's polynomial involves a's, a0, a1, 1 factor, plus a2, x minus x0 into x minus x1. This is Newton's polynomial. But since our data is not equally spaced, so we are going to use divided differences method. So we will now write this polynomial in divided difference operator notation. We know that a0 in divided difference operator notation is f of square bracket x0. a1 is f of square bracket x0 x1 x minus x0, and a2 is f of square bracket x0 x1 x2. So this is the polynomial in divided differences form. So to plug the divided differences here, the values of f of x0, f of x0 x1, f of x0 x1 x2, we will have to construct the divided differences table. So we have the data containing x values and y values, which are -1, 1, 2, 5, 1, 3. So we have data x, y values -1, 1, 2, 5, 1, 3. Let's construct the divided differences. We will name the x and y values x0, x1, x2, y0, y1, y2. And f could also be written as f of square bracket x. In the place of x, we are just putting a dot representing one x value. Now the third column will have a name f square bracket. These two dots indicate they are going to be two x values in the notation for every term in this column. So first we calculate the difference between 5 and 1. So this divided difference is calculated like this: 1 minus 5 divided by the corresponding x values differences, or whatever we are going to get here will have the notation f of the first two x's x0 x1, and divided by the difference here is the difference between the last x and the first x, x1 minus x0. So x1 is 1 minus x0 is -1. So we get here -4/2. which is minus 2. So here we have gotten the value of f of square bracket x naught x1, which is minus 2. Next, we will calculate this difference between 1 and 3. The value here will have a name f of square bracket x1 x2. So the value of f of x1 x2 will be calculated here. Since arrow is in between 1 and 3, so it's the difference 3 minus 1 divided by the difference between last x and the first x, that is difference between x2 minus x1. So x2 is 2 minus x1 is 1. So we have f of square bracket x1 x2 equal to 3 minus 1, it is 2, 2 minus 1, it is 1, so we have 2. So we can put an arrow between minus 2 and 2. We will get the value for the third column. The third column will have square bracket, f of square bracket and 3x values inside. So we have put 3 dots. So the first value that we are going to get here is f of square bracket x naught x1 x2. And how we calculate this? Since the arrow is in between minus 2 and 2, so we will calculate second value minus first value divided by difference between the last x, which is x2, and the first x, which is x naught. x2 minus x naught, 2 minus 1. So we simplify this. This is 4 divided by 3. So we have the value of f of square bracket x naught x1 x2. So now we will plug the differences from this table into the 2-degree polynomial written in divided differences form, which is this. Let's plug in the values in this polynomial from this table. So we have p2 of x equal to f of square bracket x naught is f of x naught, which is same as y naught. So the value of y naught from the table is 5 plus f of square bracket x naught x1. From the third column, the first value, it is f of square bracket x naught x1, which is minus 2. X minus x naught is minus 1 plus f of square bracket x naught x1 x2, this value is 4 by 3 into x minus x naught is minus 1 into x minus x1, which is 1. So the polynomial here is 5 minus 2 x plus 1 plus 4 by 3 x plus 1 into x minus 1. We have the polynomial which is same as the function f of x, which is same as the function y. So we have constructed the polynomial by using the divided differences method because the data was not equally spaced. If the data would have been equally spaced, we would have used either the forward differences method or the backward differences method. So we have constructed the polynomial, but that is not the end of what we are looking for. So here we had to find the derivative of the function at 3. So first we have to find the derivative. That is, if we have the function, we have to find its derivative with respect to x. So it is derivative of y with respect to x. So what we shall do is, for the polynomial y, we will differentiate this expression with respect to x. So left side gives us dy by dx, which is same as y dash equal to derivative of 5 with respect to x. 5 is a constant, so its derivative with respect to x is 0. Minus 2 is the constant on the side. Derivative of x with respect to x is 1. Plus derivative of 1 with respect to x is 0 because 1 is a constant, plus 4 by 3 outside. And now we have to find the derivative of x plus 1 into x minus 1 by the product rule of the derivative. So what does the product rule do? You call one of the terms as 1 and another 2. So the derivative by the product rule is first term as it is multiplied by derivative of second term. Second term is x minus 1. So derivative of x minus 1. Derivative of x is 1 minus derivative of 1 is 0. So 1 minus 0 is the derivative of x minus 1 plus first term derivative. First term is x plus 1. So derivative of x is 1 plus derivative of 1 is 0 and the second term as it is. So we have used the product rule to find this derivative. And now we will simplify. This will become x plus 1 plus x minus 1. So this term x plus 1 plus x minus 1 is the derivative of x plus 1 into x minus 1. So here we will put this derivative, which is x plus 1 plus x minus 1. Please see that for the term x plus 1 into x minus 1, we have used product rule of the derivative to find this derivative x plus 1 plus x minus 1. Now that we have differentiated the expression y with respect to x, we will simplify. Y dash is equal to minus 2 plus 4 by 3 2x plus 1 minus 1 is 0. So we will just close the bracket. We have the derivative, but remember we have to find y dash at 3, means at x equal to 3. This is something we have to find. So in this expression, y dash minus 2 plus 4 by 3 2x, in the place of x we will put 3. So we write it y dash at x equal to 3 will be minus 2 plus 4 by 2 into 2 into 3. Let's simplify this. We have minus 2 So we have found y dash at 3 at x equal to 3 as 10. So for the given data here, we constructed the polynomial by using the divided differences method. For that we had to construct the divided differences table, and from the table we plugged in the differences in the divided differences polynomial. Once we had the polynomial, we had to differentiate the polynomial with respect to x. Polynomial is also called here the function y. So we differentiated y with respect to x, and after differentiation we plugged x equal to 3 and we got y dash at 3. So this is how we solve this kind of numerical differentiation question. In the next video, we will construct the polynomial by using forward differences method and then differentiate that polynomial, and after differentiation we will plug some x value.